Now let's see how brackets in a formula affects the relative mass of the compound. In this particular case we're going to have a look at copper hydroxide. Copper hydroxide is an ionic substance and as such exists as a giant structure of ions. However, the simplest possible ratio of ions within the structure, copper hydroxide, corresponds to 1 copper ion and 2 hydroxide ions. So the formula shows the 2 hydroxide ions in a bracket where there's a group of atoms that must stay together, as in the hydroxide ion, and these are multiplied. We put these in brackets. So that means that in order to find out the relative formula mass of copper hydroxide, that's the mass of the simplest formula unit, we need to look up copper, oxygen and hydrogen. So from our periodic table, copper has a mass of approximately 63.6 or 63.5 in some books. Oxygen has a mass of 16, hydrogen has a mass of 1. And so we look at the formula. The formula tells us there is 1 copper and 2 OH groups. So copper, 1 copper atom has a mass of 63.5, 2 hydrogen atoms have a mass of 2, and 2 oxygen atoms have a mass of 32. The total of all the masses is 97.5, and so the relative formula mass of copper hydroxide is 97.5. Now let's have a look at another example, ammonium sulfate. Ammonium sulfate is a giant ionic substance. It has the general formula, it has the chemical formula NH4 This means that the simplest formula unit consists of 2 ammonium ions and 1 sulfate ion. So in order to find the relative formula mass we need to look up nitrogen, hydrogen, sulfur and oxygen and multiply them appropriately. We need to find the mass of 1 ammonium ion and then multiply it by 2 and add in the mass of a sulfate ion. So looking at the periodic table, nitrogen has a mass of 14, sulfur has a mass of 32, hydrogen has a mass of 1 and oxygen a mass of 16. So in NH4 there are 2 nitrogen atoms. There are 8 hydrogen atoms, that's 4 times 2. There is 1 sulfur atom and 4 oxygen atoms. When we add these together we get 132, so the relative formula mass of ammonium sulfate is 132.